Algebra 1 Common Core, Unit 5, Section 5, Intercepts. So the past couple of videos have been mostly about slope, but we talked about in video 5.3 that to really know a linear equation or to graph a line, you need to know two things about it. You need to know its slope, meaning like its steepness, its angle of elevation or incline or decline kind of thing. So you need to know its slope and you need to know its location. You need to know where it is. I need to know a point on the line so I know where to graph that line. And the easiest points to work with are the intercepts, specifically the x-intercept and the y-intercept. Now, this little top box up here is talking about the x-intercept. So it says intercepts are where a line or curve intercepts something such as an axis. Remember, the x-axis is our horizontal axis. Every point on the x-axis has a y value of 0. Like if you were to look at a big graph here, maybe I don't know, I have a graph on the next page. I have a graph down here. Notice that every point on this x-axis, like here, 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 if I were to state these coordinates, it would be 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0. Right, this is 0, 0, of course. Negative 1, 0, negative 2, 0, negative 3, 0, negative 4. All of the points on the x-axis have y values of 0 because they're not up or down at all. They're just left 5 and stay there. That's 5, 0. Right 5 and stay there. Left 3 and stay there. It's negative 3, 0. So that they all have a y value of 0. And we could use that little fact to help determine our x-intercepts. So since we know they have y values of 0, we can substitute in 0 for the y value and then solve for x. So for example, a little equation here, y equals 2x minus 6. We can replace the y with 0. And so it's 0 equals 2x minus 6. And then you could solve this very simple little equation for x. It would involve by first add 6 on both sides, add 6 on both sides, and then you get 6 equals 2x divided by 2, and x equals 3. Which means 3, 0 is the x-intercept right here, 3, 0. Now the y-intercept is basically the reverse. The y-axis is our vertical axis, and every point on here has an x value of 0. Again, if we look at this is 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, negative 2, 0, negative 4, 0, negative 6, 0, 0. Right? They all have x values of 0 because they're not to the right or to the left at all. They're just straight up and down on the y-axis. So because they all have an x value of 0, to find the x-intercept, I plug in 0 for y. Well, to find the y-intercept, I could plug in a 0 for x. So for that same equation, instead of changing y to 0, I could change the x to 0. And so it's 2 times 0 minus 6. 2 times 0, of course, anything times 0 is 0. And we just get negative 6. And this is also the reason why when we have y equals mx plus b, we say that b is our y-intercept. Because if I plug in 0 here, this whole thing is going to become 0, and then I just get y equals b. b is the y-intercept. Because when x is 0, b is all you have. And so in this case, negative 6, or 0, negative 6 is the y-intercept. So finding the intercepts is pretty easy, and I think it's helpful to remember kind of the reverse nature of them, that if I want the x-intercept, y is 0. If I want the y-intercept, x is 0. And so it's always kind of reversing that. So for the examples down here, let's find the x and y-intercepts. First, let's find the x-intercept of everything. Graphically, the x-intercept is, and y-intercept are simple. You're just kind of looking on the graph. The x-intercept for this black line here would be negative 2. The x-intercept for this blue line would be 0. So for this one, the x-intercept is negative 2. And for this one, the x-intercept is 0. And what that means is, it's negative 2, 0. 0, 0 is another way of writing it. The x-intercepts on equations over here on the right, that's a little bit harder. So for the x-intercept, we make y equal to 0. So we're going to do 0 equals 2x minus 6. Is that same equation from up here? 2x minus 6? Wow. it is. But anyways, we'll finish it. So we'll add 6 on both sides, add 6 on both sides. 6 equals 2x, divide 2, and we get x equals 3. So the x-intercept is x equals 3, which is the coordinate 3, 0. For this next one down here, what we could do is we have a couple of options. I could get this in standard form. I could rewrite it into a y equals mx plus b and then do what we've been doing. Or I could leave it as it is and just plug in 0 for y where it is. But let's practice standard form since that's something we need to do a lot here. So if I want to get this as y equals, the first thing I would do is minus this 5, minus 5. And so that's 3y equals negative x minus 9. And then divide everything by 3. Divide by 3. Divide by 3. That's going to give me y equals negative 1/3 x minus 3. All right, so I can work with either one of those equations, but I want to work with that one. And the first thing I do for the x-intercept, I'm going to do all my x-intercepts in green, is I replace the y with 0. So 0 equals negative 1/3 x minus 3. My students know that whenever I'm solving the equation with a fraction, I like to multiply it out. So if I multiply everything by 3 here, so multiply everything by 3, switch to blue here, times 3, times 3, times 3. 0 times anything, still 0. These 3's cancel out, so I should get negative 1x. So negative 3 times 3 is negative 9. And then we can do a couple things here. I could add 9 to get positive 9 over here, and it equals negative 1x, and divide. I'm going to end up with x equals negative 9, which is the point negative 9, 0. Remember, your x-axis, y is 0, so we're going to get a y value of 0. All right, so that's our x-intercepts. Just where is it on the x-axis, and plug in 0 for y and solve. For the y-intercepts, again, on graphs, I could just see where is it crossing the y-axis. For this black line here, it's negative 4. So the y-intercept is negative 4. That's not negative 4 comma 0 for the y-intercept. The y-intercept's x is 0, not y 0. So it's 0, negative 4, as opposed to like negative 2, 0. Right? The x-intercept, y is 0. The y-intercept, x is 0. For this one, it's still 0, 0. That's also the y-intercept. Because 0, 0, they're both 0. It's at the origin, it's called. For this y equals 2x minus 6, I know we already did it up above, but I'll kind of do it again anyways. So the y-intercept, we keep y as y, but now we replace x with 0. 2 times 0 minus 6. And y equals, the nice thing about the y-intercept when it's in standard form is you don't have to move anything side to side because you're solving for y, and y is already low and on the left. You just got to simplify the right side. 2 times 0 is 0 minus 6, and 0 minus 6, of course, is negative 6. But you could also, when you're in standard form, just look at the constant. Because this is in y equals mx plus b, I could see the y-intercept is negative 6. See, y equals mx plus b, y-intercept is b. X-intercept you can't just see from the equation like we can y-intercept. So y-intercept is a little bit easier to recognize. That's why we talk about it a lot more. Let me just extend this page and I'll do the y-intercept here. So my equation in standard form is negative 1/3 x minus 3. And like I said, right there I know my y-intercept is negative 3. But I'll show the algebra that when I replace x with 0, I get y equals 0 times negative 1/3. Well, 0 times anything is 0, minus 3. And 0 minus 3 is negative 3. So that is 0 comma negative 3. The y-intercept is 0, negative 3. And this y-intercept was 0, negative 6. I see a lot of students sometimes, they get the y-intercept like negative 3, but then they write negative 3 comma 0. Remember, this is y, and y goes second. We plugged in 0 for x. That goes first. So your x-intercepts are something comma 0, but your y-intercepts are 0 comma that something. So that's it for intercepts. Again, remember, like I said, that opposite nature, that to find x, 0 for y. To find the y-intercept, 0 for x. And, a little bit of basic math there. But the nice thing about y equals mx plus b is you could just see the y-intercept. So that's the one that we'll talk about the most. Because really, like I said, to graph a line, I need to know its slope and where it is. And to know where it is, I just need a single point. And so the y-intercept is the more common point that we'll talk about here. But that's it for finding intercepts algebraically. See ya.